Dear students, welcome to another session of section of solids, and today I'll be discussing the steps involved to solve the questions on section of solids. What are the steps? How do you start the question? When you have the statement just right in front of you, you have to go through the statement. What things are required from the statement to make it necessary for you to start from the first step, right? And I think most of the students get confused in the statement, so they are not able to judge where is the first step, where to start the question from. So in today's session, it will be a very short session. I'll be making you understand about how to start your question, which is the first step, which is the first projection that you have to make in the actual drawing. So let's start the session. In this way, we'll focus on the question. We'll read the statement very carefully, and things that you will note in the statement would be the type of solid. What is the type of the solid that would be given in the question? So it can be a prism, it can be a variety of a pyramid, it can be a solid of revolution. Now, three things that you have to note further in the type of solid is that first is, if it is a prism, what is the shape of the base of the prism? You all know that shape of the base of the prism is polygonal. So if it is a prism and it has two bases, the next thing you have to note in a pyramid is, if it is a pyramid, it still has a polygonal base and it has one polygonal base and an apex. Third is solid of revolution. For solids of revolution, we have two types of solids. One is a cone, one is a cylinder. In both the solids, the shape of the base is a circle. The difference is only, if it is a cone, it has a one circular base and an apex. If it is a cylinder, it has two circular bases. Alright. So these points you will have to remember when you are reading the statement. The first step would be to take into account what is the type of solid, a prism, pyramid, or solids of revolution. Second, if it is a prism, it has one base. It has two bases. If it is a pyramid, it has one base and an apex. If it is a solid of revolution, it has if it is a cone, it has one circular base and apex. If it is a cylinder, it has two circular bases. Alright. Next, we'll look into the point, which is the orientation of the solid. Now, the orientation of the solid means what is the position that the solid will take with respect to the principal planes of projections. Now, the principal planes of projections here are HP and VP. Orientation, by orientation I mean to say is that if the solid is resting along its base on HP with its axis perpendicular to the base and the axis parallel to the vertical plane. I'll explain in details about each and every point here: the type of solid, the orientation of the solid, and type of cutting plane. We already had a session with the type of cutting plane. The third thing that you will notice is the type of cutting plane. Now, the type of cutting plane you all know is AIP, AVP, HSP, and VSP. Now, there is a difference between all of these four planes, and it will be the last priority to take into account the cutting plane, because first we will take the type of solid, then we'll take the orientation, and taking these both two types will project the solid first, and then at last step would be to organize the cutting plane on the projection of the solid, and then the final step would be to project the sectional views. Now, over here in the drawings, I have made three type of solids. Two are from the solids of revolution, like this and this. This is a cone, this is a cylinder, and one is from a prism. So the name of the solids, why this cone is called as the solid of revolution, because if we take a right angle triangle and try to fix it axis and try to make it give it a revolution of 360 degree, it generates a cone. Likewise, if we have a simple rectangle and if we try to keep one side, longer side of the rectangle fixed and then generate about that fixed side, it will give you a cylinder. So the generation of a cylinder and the cone is through the revolution, and that is why these solids are called as the solids of revolution. For the next solid, which is a square prism, the name of the square prism has it is called as the square prism. This name has come by the shape of the base. So the shape of the prism is the shape of the base of the prism is a square. So over here the name is taken from the shape of the base of the prism. Now the shape of the base of the prism is a square, that is why it is called as a square prism. And now if you all know that prism is a solid that has two equal and similar end bases which are joined together with a rectangular face, which are joined together through the rectangular faces. So the number of sides in a square base will be 4, and number of faces thus formed to join the two bases will be also equal to 4. So that is why it is called as a square prism. Now things to note in the first point that I have told you, that after reading the question you would have to guess which is the type of solid. And when I say which is the type of solid, you have to actually imagine in your mind that this is a cone, it will look like this. This is a cylinder, it will look like this. You should have a picture in your mind that if it is a prism, it will have two bases. The bases will be in the shape of the square and they will have 4 rectangular faces. So the picture should develop in your mind when you are arriving at the solution to the problem. So the first step to it is you have to guess, you have to make up your mind about what type of solid is given in the question. Second is, if I have taken here a cone, now the base, this is the base of the cone, right? And through the base, through the center point from the base till the apex, the sharpened edge, here a line, an imaginary line passes through it. This will be called as the axis of the solid, and axis of the solid will tell you about the height of the cone. Height of the cone, axis of the solid will tell you about the height of the cone. And the free surface around it, this is the free surface around it, this will be called as the lateral surface of the cone. So the base of the cone is a circular in shape, and thus I can say that the solid in the second step, if I proceed towards the second step, I would say that the cone is resting on its base on HP. The cone is resting on its base on the vertical plane. So it means that if this circular base is towards HP, the apex will be pointed towards the top view. If the circular base is resting on vertical plane, then the apex will be pointing towards the front view. Alright, similarly for a cylinder will have a circular base 2 and circular base 1. So a cylinder would have 2 circular bases, and the line, an imaginary line that passes through the center of base 1 to the center of the base 2 will be the axis line of the cylinder, or the axis line of the cylinder would tell us about the height of the solid. So in the statement it would be given to you as a cylinder is resting on its base on horizontal plane with the diameter, this d is the diameter of the circular base, is given to you as so and so, and the height of the cylinder of the axis of the solid is equal to this much length. And all the lengths, all the units that are taken here in the projection of any solid or any object is taken as in mm. All the lengths will be taken as in millimeters. Alright, so for the next, and this free surface of the cylinder, the smooth surface, the smooth part of the cylinder is the lateral, not the later, is the lateral surface of the cylinder. Alright, so moving towards the square prism, a square prism, now prism has two bases It is not circular base. If it was a circular base, it had been a cylinder. Now the shape of the base is a polygonal. Why we say polygonal? Why we say polygonal? Because in a polygon it has equal and similar, equal number of sides, equal and similar sides, and all the sides are equal, right? So we can say that polygonal base, if it means that it is a shape which is formed by changing the value of n. N stands for the number of sides. If it is 4 sides, if there are 4 sides, it is square. If there are 3 sides, it was a triangle. If it is having 5 sides, it will be a pentagon. If it is having 6 sides, it will be a hexagon. So over here we have 4 sides, so it is forming a square, and that is why it is called as square prism. Why prism? Because it is having 2 bases, 2 equal and similar opposite end bases. These 2 bases are at the end of the solid, and that is why it is called as, because it is also a square. Base 2 is a square, base 1 is a square, and they are at the end. It is called as the end bases, equal and similar end bases. Both the sides, A here and A here, it is equal. Now the axis of the solid of the square prism is again through the base of through the center of the base 1 and through the center of the base 2. This is an imaginary line, and you all know during the projection of solids you used to project this line with the help of a long chain thin line. A long chain thin line is a line which is forming a combination of a long dash and a short dash, a long dash and a short dash. So this is how you will develop the type of solids in your mind, and you will note down certain parameters. For example, here the side of the length of the side of the base, over here the diameter of the circular base, the diameter of the circular base, the height of the cone, the height of the cylinder, the height of the square prism. And in the square prism, all the faces, the bases are joined together with the help of rectangular faces. If so, there is an objective question for you. If the side A in a square prism is equal to 40 mm, alright, is equal to 40 mm, and the axis of the solid is also equal to 40 mm, what will it be? Will it be a square prism or will it be another solid? Can you name the solid? It will be a cube. Then it will be a cube, because all the 6 faces would be of equal length. All the 6 faces will be of equal length, and the shape of the face and base will be similar in a cube. So to make a rectangular face to a square face, what we need to do? We need to just make the side of the base of the prism and the height of the solid equal. So if this is 40, this has to be 40 to make this rectangular face to a square face. Now talking about the orientation, I was talking about base towards HP, base towards VP. So this base is resting on the HP horizontal plane with the axis of the solid perpendicular to the base. Axis of the solid at this point will also be perpendicular to the horizontal plane. Axis of the solid will be parallel to the vertical plane. Axis of the solid, base resting on the solid, base of the solid resting on HP, axis perpendicular to HP, and axis of the solid parallel to the vertical plane. So about these points, the orientation of the solid, I'll make you explain about the orientation by using this example, which is a cylinder. I'll be making here a vertical plane and making here a horizontal plane, so as to explain you how come the base is on HP and it makes with its solid axis is also perpendicular to HP and solid axis parallel to the vertical plane. Just a little pictorial presentation of how this solid orients its position with respect to the horizontal plane and the vertical plane. Let's see. Now over here in this question I have made an example on the board This is an HP, this is a VP, this is a first quadrant that I'm assuming, and the solid is a cylinder. It has a imaginary line passing through the center of base 1 to the center of base 2. I've just elongated this center line so as to show you that the axis of the solid is perpendicular to the vertical plane. So here, if this line is perpendicular to VP, axis of the solid is parallel to HP. This axis or the imaginary line is parallel to HP. Base is on the vertical plane. So in this situation, we can assume that the base of the cylinder is on VP. Also, we can assume that the base of the solid or the base of the cylinder is parallel to VP. And the last condition is the base is perpendicular to HP. Now, how this base is perpendicular to HP? So I'm taking the assumption that if this is the circular base and it is parallel to vertical plane, like here in the third condition, so the surface is perpendicular to the horizontal plane. So all of these four assumption goes about with the orientation of the solid. None of the assumptions here is false. All the assumptions are true about the orientation of the solid with respect to horizontal plane and vertical plane. This is the example number 1. We'll do about various examples in this form so as you get the basic idea about the type of solid and its orientation with respect to the horizontal plane and the vertical plane. It is just a mind exercise, and if you will do this exercise over and over time again, it will be very easy for you to solve any subjective question or the subjective answer or the objective question. So all the objective questions will be made from these assumptions and the orientation of the solid with respect to HP and VP. Let's do it. In another example, I've taken a solid. Can you guess the name of the solid? It is a, how will you guess the name? It's a square base and triangular faces. So it means it is a square pyramid. So in this square pyramid, I've taken the following assumptions. These assumptions are, I've taken the base of the solid on HP. So it could be the base on HP or the base is parallel to HP, right? The square base of the square pyramid is on HP, or the square base of the square pyramid is somewhat above the ground, above the horizontal plane. It means that then the surface of the square pyramid or the base of the pyramid, which is a square, will be parallel to the horizontal plane, uplifted from HP. Axis perpendicular to HP. So how is this assumption working? This is the green line, is the axis line that passes through the center of the base of the solid. So the axis line starting from the apex and till the center is perpendicular to the horizontal plane. Axis of the solid is parallel to the vertical plane. Base edge is perpendicular to VP. Now this is the square base. You can see two of the edges from the base, square base. Two base edges, they are parallel to vertical plane. Two of them are perpendicular to the vertical plane. So I've taken base edge perpendicular to VP. This is the base edge perpendicular to vertical plane, and this is the base edge which is parallel to the vertical plane. To make it explain to you, I can name A, B, C, D. So I can say that edge AB and edge CD is parallel to VP. Edge A and D and edge B and C is perpendicular to the vertical plane. I hope you have understood about the assumptions that I've taken. So these assumptions are actually the orientation of the solid with respect to a vertical plane and the horizontal plane. Let me assume another example. So in another example, I have assumed a solid which is a cone. This is VP This is HP, you all know. If it is like this is first angle. Orientation of the solid. So in this orientation, I can see that the solid axis is inclined to HP. If the solid axis is inclined to HP, the solid axis is parallel to the vertical plane. So these 3 points coexist at the same time. Axis inclined to HP, axis parallel to VP, and the base point on HP. So you can see that the circular base, this one point, is on the horizontal plane. As you all know, in this type of orientation, when you have a solid whose axis is less than 90 degree to HP, then you have to solve this question in two phases. So in the phase 1, you will assume that the axis is perpendicular to HP, parallel to VP, and in the second phase you will assume the axis will take the axis which is inclined to HP and parallel to VP. So phase 1 would be a very simple, that axis will be perpendicular to HP and parallel to VP. In the phase 2, axis inclined to HP and parallel to VP. So this type of question will be solved in two phases, phase 1 and phase 2. Phase 1 for front view, top view. Phase 2 front view and top view. Alright, we'll assume the next orientation. In this another example, I have tried to make a solid which looks like it is inclined to the vertical plane. So here I have assumed a square prism. It looks like a little like a brick, but it is a square prism with its axis inclined to VP at some angle, and the axis is parallel to HP. This is HP, this is VP, axis is parallel to HP, axis is inclined to the vertical plane. So the first assumption or the orientation is that the solid axis is inclined to vertical plane with the solid axis parallel to the HP. Then the face of the solid is also parallel to HP, and like we initially solved the question in phase 1 and phase 2, it will also be solved in phase 1 and phase 2, with the assumption that in the phase 1 the axis of the solid will be taken perpendicular to the vertical plane, parallel to HP, and in the phase 2 the actual angle of inclination with the vertical plane will be taken in phase 2, and then it will be projected as per the statement in the front and top. So phase 1 and phase 2, like this. So to go more on this, I'll be sharing with you some of the objective questions now, and I'll be making a picture, small picture, and you have to tell me out of the 4 choices which answer could be true. Just an example of a question. Your questions could be very different from these ones, because I'm actually letting you know how to solve these questions. If this is the picture which is given to you, and this is it says question asks you that what is the axis of the cone is for example, first point is perpendicular to VP, parallel to HP, perpendicular to the base of the solid, and inclined to HP. So which one of the 4 options are true? Let's see the first option. It says axis of the cone is perpendicular to VP. So where is the axis? From the point of apex till the center of the base, this is the imaginary line, and I can see that it says it is perpendicular to VP. No, it is perpendicular to HP. Second option, parallel to HP. Axis is like this. If it is perpendicular to HP, on the other hand, it is parallel to the vertical plane. Correct. Incorrect. This is incorrect. First is incorrect, second is incorrect. Let's look at the third point. It says perpendicular to the base of the solid. This is the axis line. It is perpendicular to HP, and with if it is perpendicular to HP, it is also making an angle of 90 degree with the base of the solid. So this base of the solid is circular, so it is perpendicular to the base of the solid. So third part is correct. Inclined to HP. I cannot see the axis line inclined to HP. It is already proved in the question that it is perpendicular to HP. right? So the third option is correct as per the given pictorial presentation. This is how you will be solving the questions. If any statement is given to you, for example over here the question is in pictorial presentation, so there is no statement, and the question asked you further is axis of the cone is. So over here you can actually, either way you can use the statement and make a rough presentation and then solve the question, or you can simply have the pictorial presentation of the solid with respect to HP and VP, and then you can give the answer to the asked question. So over here, if the pictorial presentation is like this, I can actually help you making the statement of the question. What would be the statement of the question? The statement would be, noted very clearly, a cone is resting on its circular base on HP with the axis of the cone perpendicular to HP and parallel to VP. Alright, like this. So the correct answer is, it is perpendicular to the base of the solid. Alright, I hope you have understood about the today's class, and if you have any kind of problem solving the objective questions, you are openly asked to comment in the comment box in this video. And if you want me to present or make a video on any other lecture or any other topic that you have not understood, I'll be happy to do that. All right, thank you for watching.